Hey there, gentlemen. So I promised to do a little upload on some of the things that might have not been hit on that I learned along the way for getting my iNAV set up. I'm coming at this from never soldering onto a flight controller board before. I've had a quad for 6 months and know my way around Betaflight pretty good, to the extent that I've tuned my quad, my PIDs on my quad and things of that nature. I pretty much know what all the settings are in Betaflight at this point. So iNAV is very similar to that, so I do have that background, but just for, you'll see in a second here, the basis of the tips. Starting off, soldering iron. Had a soldering iron before, but it was more from, one with the trigger and the whole deal. So I needed to get one, a handheld, finger point one. I got this one because I'm cheap. And this thing worked great. Gets super hot. There's a very, very fine point tip that comes with this that's great for soldering your pins on your flight controller board. It has an adjustable temperature, but I wouldn't say it's really temperature. I would say it's power. So you can turn the power down or turn the power all the way up. I use the fine tip for that, and then the blunt tip, the bigger tip for everything else, just soldering on the XT60. But this thing gets hot, and it gets hot fast. And it works great, so check that out. Obviously, I got if you're in the States, make sure you get the English, or the plugs for the 110 volt. Next tip, these DuPont wire jumpers. Instead of getting servo extensions, I took a risk a little bit and got these. They're inexpensive. You just pull off the wires that you want, and then when you want to make a pair of them, if you glue these side by side, I just took a little CA glue, like when I noticed, okay, I need, like for my GPS on my flight controller board, it's the GPS signal in, out, power, ground, SDL, SCA, or whatever those numbers are for the magnometer. They're all, so I just plugged them in and said, okay, got that working. Yep, those are right. Pulled them out and just glued all the dew points. These connectors here side by side. These are great because you can snip them or snip one side or the other. They're just very versatile, and then you have that array of colors you can use. So you can do that instead of servo extensions. And for $3 for 40 of them, $3.50 for 40 of them, it's not too bad. Off to the flight controller board. One question I had initially was I wanted to power, so I used an Omnibus F3 board. I use this board. Figure an F3, I think it runs at 2% CPU utilization, so it's plenty of power in the F3. The only thing this doesn't have is a current sensor. If you want a current sensor, you need a V2 board. I didn't care as of this point about the current sensor. This does have OSD in, out, so on and so forth. I think the board was like 18 bucks on eBay. So pretty cheap. I did want to power with VBAT, so looking at these pins, I'm sure this is relative to other boards as well. So I took two DuPont connectors, wired them into the, I had my pin headers that I wired into this whole thing, so the DuPont's just plugged into it. Two DuPonts for ground and VBAT, just took two leads off the battery wire, going back to the ESC for the airplane, and just kind of spliced off of that at a spot and plugged that in. So that gives my board battery voltage. But then on this side, I'm also plugging in my ESC, which also is powered by battery voltage, and then has a BEC in it to produce 5 volts power, because normally without a flight controller board, that throttle cable with the that's coming from the ESC is powering your receiver, your RX. So in this case, I was like, is that okay? So now I'm feeding battery voltage here, which this is dropping down to 5 volts and powering the servo rail. Can I plug the back cable into here as well? That's also powering 5 volts? The answer is yes. Actually, this one through the VBAT and what this board is doing, at least, and I would think this is the same for others, it was giving me, I think, like 4.87 volts, and I believe from the back I was getting like 4.95 or something, like 9.8, something like that. It was closer to 5, so the back was actually producing a little bit more power. Nothing fried, everything worked fine. Honestly, one of the complaints on this board specifically is that the resistor gets really hot for 5-volt battery power. Now, I haven't tested it either way, but I would assume that would allow the ESC, so when there's an amp draw from the servos and for the receiver, that it would allow the ESC, or the BEC and the ESC to take on some of that load. So some of the load could be coming through the flight controller board, because you have a voltage drop, right, when these servos would draw power, and some of the load could come through the BEC. So it gives it 2 channels to get 5 volts. For up here, this is where powering the camera and the VTX. So this diagram is not very good here. So it says this is ground, this is RAM on this controller, which in this specific one you can power the RAM rail essentially by either jumping these two together, and then that would give battery voltage to this RAM, these outputs here, these jumpers, or you can give it 5 volt by jumping these two together. So that's what that is. So in mine I just provided the camera, which is a Foxeer, and my video transmitter with battery voltage. A couple reasons. If you have higher voltage, you need less amps, so you shouldn't get as much heat with higher voltages. And secondarily, I'm not using that resistor. That resistor's not in the way, so it's just getting the battery voltage going through. So it's not, because if I power with 5 volts, now you have 600 milliwatts plus the camera sucking down on the 5 volt supply that's on this board. So you don't have that in the way. A better diagram here is the video out as these rails. So this was ground power, and then signal out. Video in is ground power, signal in. So that's specific to this board, but nevertheless. So just the doubling, the double power source wasn't an issue. A couple things, switching over to iNAV. So I'm flopping iNAV here. One thing you got to do is, Matt Ogborn has a video series on iNAV. You need to watch this whole thing. Just do it at one chunk at a time. He talks about variables to enter into the iNAV configurator in this introduction of iNAV. That's important. All these are important, but don't skip that one. These will tell you how to wire up everything, as you guys know. Those variables are on the website. Make sure they're right here. You got to change these defaults. These could be a make or break, so they're noteworthy on mentioning, because you don't want your plane to go into failsafe if throttle is low for 10 seconds. That would not be fun. So yeah, do those. Tip. Next, return to home. Let's, start on failsafe. I am powering, or the signal from my receiver to my flight controller is a PPM signal. I had an issue with my omnibus where normally, the PPM signal is coming across the PPM pin here, so it's PPM, right? And you just plug in one wire in. Normally you would go back to iNAV here. That's also using UART3. You have to look in the literature for your board. Normally if you're using a PPM signal, you would not have serial RX checked here. Honestly, if you would check serial RX, it would make it not work. But for my omnibus board, if I didn't check that, the PPM signal wouldn't come through. I don't know, that doesn't make sense, but whatever, it works. So if you're having trouble with your PPM signal, give that a shot. Next, to get failsafe to work, you need to, I'm using a Spectrum receiver, and everybody else in the World's using, FlySky or FreeSky or whatever. But you need to get failsafe to trigger. I know with at least Spectrum and my receiver, which is a Redcon receiver, the only way to do that is I had to get my failsafe mode of my receiver. So when you shut your transmitter off, your receiver goes into failsafe itself, and it centers the servos and it sets the throttle. It's basically goes to the positions you had when you bound your transmitter to it. So you want to have the throttle stick low and the switches where you want them to be and all that kind of stuff. So that's what first happens when your transmitter shuts off or it loses signal. Your receiver goes into failsafe. Well, how does that tell your flight controller? Well, it needs to send pulses outside of these ranges. So I think for FlySky you can tell it to send no pulse, and that would do that. For mine, what I needed to do is put my throttle stick all the way to the bottom, change the range up to 120%. So that's the farthest the throw range can be on your throttle, and then bind the receiver there. In that scenario, when I turn off my transmitter, my receiver sends a pulse of 950, around 956 microseconds to the flight controller. And since that's below the 985 microsecond pulse length, it triggers, it says to the flight controller, hey, he's in failsafe. If my transmitter is on, my normal flying to have my receiver, when I'm at low throttle, it gives the 1,000, and high throttle, it gives 2,000. That, when my receiver's on, it never provides a signal that low. Now I have my receiver turned off right now, or turned off, and you can see the little failsafe mode is triggered up here. There might be different ways with your transmitter and setup to do it. The end result is you need to work with your software here in transmitter so that when you turn your transmitter off, this little parachute turns on, and then obviously the one thing I want to do is return to home. You have to tell it what action you want it to do. So the microsecond thing is the tip there to keep that into consideration if you can't get it to work. The return to home mode. So I also wanted to switch iNAV return to home, which this mode does not show up unless in your configuration tab you have GPS enabled, which you can't do unless you have the GPS wired up. So you first got to get the GPS wired up, working, and then you can enable this, and then you can go into the modes and then have the mode for return to home. With that, when you sit at your desk and mess around with your transmitter with the props off, normally these modes highlight. So if I switch into horizon mode, this will highlight indicating that mode is triggering. When auxiliary 2, when the receiver, when the pulse goes up into this range for auxiliary 2, which is when I flip the switch up, this will highlight indicating that mode's working, and then you can test them all. I could never get nav return to home to highlight because I was arming. To get nav return to home to work, you have to arm the plane, walk 20 meters away, then you can trigger the mode and then it will highlight. Return to home modes or failsafe on return to home will not work if the plane is within 20 meters of the arming location. So if you're on the ground doing a test, you have to arm it, walk away 20 meters, then turn your transmitter off to make sure that the plane tries to, it should power up and bank. It should try to do a return to home flight if you're holding it on the ground. If you restrict that, or you should have the prop off. But nevertheless, the 20-meter thing, it's on the wiki page. It took me a little bit to figure that out. Horizon rates. If you go to PID tuning, so one thing I first noticed on, when I take the craft and move it back and forth to show, like, okay, if I physically have it in horizon mode and I bank the craft right, does it, that the ailerons move so it tries to bank it back left? Because it should do that. It should try to counteract your actions. It's one of the things in Matt's videos to check. I noticed the throws weren't a lot. And then I also noticed in horizon mode, if I move the sticks, man, the throws aren't a lot. What's with that? We need to increase the roll rate and pitch rate. So roll is the ailerons, pitch is the elevator. I don't have yaw. I don't have a rudder on the Micro Sky Hunter, so it doesn't matter to me. But you'd have to do yaw array as well for the rudder. Keep that in mind. That's a tip. And I think that brings it to the end. So hopefully this will help. I don't think this specific stuff was covered in the videos. I didn't really have any issues otherwise. I mean, there's a lot of stuff, and this isn't all you need to know. Matt's videos really have the baseline of everything. These were just some additional little tips. And yeah, happy flying. It worked for me right out of the box, out of the gate, everything. I had it all set up. I did my tests and everything. I first threw it, went right in the horizon, everything worked great. Altitude hold mode is awesome. I really love the altitude horizon mode in conjunction with altitude hold mode. Essentially, you could hand the controller to somebody at that point. It seems like when you trigger them both together, it's actually in angle mode, so it only lets the craft bank to a certain angle, to the angle of inclination you have entered, which is a part of that thing. And it will hold the altitude of the plane, so you could really hand it to your kids or whatever, or anybody else to say, oh, go ahead and fly. It's going to hold that altitude. As long as they keep throttle up, it should keep, and if they drop throttle, then it would hold level and just kind of sink. So, but as soon as you put throttle up at all, it would ramp itself up to get up to the altitude it was initially at when you triggered that mode on. So it's really cool. I really love that. And then the return vest to give you 10 seconds to go drink a cup of coffee or something, or get your goggles on to do some FPV after you're doing some line of sight. It's really nice. I really enjoy it. All the other stuff in Matt's thing about starting off with path through, you gotta watch those videos. Don't skip those because of this. But yeah. Anyways, I hope this helps. Happy flying.